Welcome to 8.2, Parabolas. We're going to write equations of parabolas in standard form as well as graph equations of parabolas. So first, let's talk about what a parabola is. So it comes from conic sections. There's four different shapes we can get by cutting a plane through a double cone. The first one, if we cut it at a slant, is a parabola. We also could get a circle, ellipse, and a hyperbola. We're going to talk about each one of these later on. Today's parabola. Parabola is the set of all points in a plane that are the same distance from a given point, called the focus, and a given line called the directrix. The parabola's standard form is y equals ax squared plus bx plus c. Key concept here is you could also put it in vertex form. Vertex form is y equals a times the quantity x minus h squared plus k, where a, if it's positive, creates a minimum, which is the vertex, and it opens up. If a is negative, it creates a maximum, and it opens down. The axis of symmetry cuts through the vertex. Our first example here, we're going to analyze the equation of a parabola. So we have y equals 3x squared plus 24x plus 50. We're going to put it in vertex form, and we're going to identify the vertex, the axis of symmetry, and the direction of opening of the parabola. So I see that a is 3, so I'm going to factor 3 out of the 3x squared plus 24x, giving us x squared plus 8x. Then I'm going to complete the square. So I take 8x, 8 divided by 2, squared is 16. So I'm going to add 16 inside my parentheses. Since we're adding 16, we also want to subtract 16, but it's actually 16 times 3 because of the 3 in front of the parentheses. So we're going to add 16 inside the parentheses. Times 3 is 48, so we're going to subtract 48 on the outside. That way we balance the equation, we didn't actually change it. Since we're completing the square, we're going to factor the perfect square trinomial. It becomes x plus 4 quantity squared times 3, and then 50 minus 48 is plus 2. It's now in vertex form. So our vertex is negative 4, positive 2. The axis of symmetry is x equals negative 4 from our vertex. Since a is 3, it opens up, and it's actually narrower than a normal quadratic equation. Next, we're going to graph parabolas. So we have y equals negative 2x squared. So here, for this equation, h is 0 and k is 0, so our vertex is at the origin. Since the equation of the axis of symmetry is x equals 0, we're going to substitute some small positive integers in and create a table. So let's substitute in 1, 2, and 3. Should get negative 2, negative 8, and negative 18. Since the graph is symmetric about the y-axis, then the points negative 1, negative 2, negative 2, negative 8, and negative 3, negative 18 are also on the parabola. So we're going to use all these points to then make this graph. Our next example is y equals negative 2 times the quantity x minus 2 squared plus 3. The a is still negative 2, so this is the equation in vertex form. Our vertex is 2, 3. The graph of this equation is the graph of the same one as in part A, but it's been translated 2 units to the right and 3 units up because the vertex is 2, 3. But the A is the same, so we can draw the same graph, we just had to translate it. Okay. Now we need to learn a little bit more about parabolas. So there's a bunch of things here. We got the form of equation. So you got the normal vertex form here, y equals a times quantity x minus h squared plus k. Well, we also have x equals a times y minus k squared plus h. So here, the original one that we normally see is when the parabola opens up or down. But to the right, when we have x equals, the parabola opens to the right or to the left. We're going to use all of these formulas in order to help us here in the next part. So let's look at this. Example 3, 4x minus y squared equals 2y plus 13. I see that y is squared, so I'm going to then isolate y squared in the 2y. So I'm going to add y squared to the right side. Okay. Then I'm going to complete the square. So we have y squared plus 2y. 2 divided by 2 squared is 1. So I'm going to add 1 and then subtract 1 from the same side. Since I am completing the square, this is a perfect square trinomial. It becomes the quantity y plus 1 squared. And then outside we have plus 12. And then we're going to divide by 4 to get x equals. Okay, so when we divide by 4, y plus 1 squared divided by 4 is 1/4 y plus 1 squared plus 3. So that's our equation. We know that our vertex is 3, -1. Our axis of symmetry, since it's x equals, then the axis of symmetry is y equals -1. The focus is 3 plus 1 divided by the quantity 4 times 1/4, comma -1. 1 divided by 4 times 1/4 is 1, plus 3 is 4, so the focus is at 4, -1. And the directrix is 3 minus 1 over 4 times 1/4, or just 2. The direction of opening, it opens to the right since a is greater than 0. And the length of the lattice rectum is 1 over 1/4, the absolute value of that, therefore it's 4. Okay, so that is a little bit about parabolas. Good luck on the practice.